Alright, electrical AAR electrical section 5 illumination, chapter 5 lamps, part 1 recommendation lamps for locomotive passenger car lighting. Table 1 is the schedule of standard incandescent lamps for steam locomotives. Table 2 is the schedule of standard incandescent lamps for diesel electric locomotives. Standard lamps for train lighting surfaces, and table 3 filament lamps. Table 3 the fluorescent lamps. Part 2, electrical lamp characteristics. A description of the more common type of electrical lamps used in general with lighter applications are included with the following paragraphs for more detailed information suggested with the Illumination Engineer Society Lighting Handbook, as well as electrical lamp manufacturing to be consulted. The electrical lamps may be divided into two major parts, namely incandescent with the filament lamps and the electrical discharge lamps. In some of the operational incandescent lamps, there is less complexity with the electrical discharge type of the discussed first. Incandescent filament lamps. Incandescent filament lamps type are divided into two major groups for a large mixture, large and miniature. Although the no show of dividing the line between the two groups in large classification generally refers to those large bulbs, medium and mogul bases, which are operational in circuits of 30 volts or higher. Our general lighting lamps are large lamps, as well as those many specialized applications such as locomotive train lighting, spotting, flood lighting, and miniature lamps are mainly the type of those such as automotive flashlights indicating the telephone switchboard, etc. The major of these types they are relatively low voltage type lamp. Basically, an incandescent filament lamp consists of the tungsten filament hermetically sealed with vacuum in air or gas, usually argon, special percentage of the nitrogen with a gas bulb. The filament is connected with the lead wires in which are brought through the glass and connected with the base. Lights are the end produced with the heating of the tungsten filament incandescent by the passing electrical current through it. In common practices, large lamps 1/3 of an amp with a high rating with the glass filled with the use of the inert filling gas to coil the filament and cause with the marks from the improvement of the lamp efficiency over those obtained with the vacuum lamps, because so the filament may be operated with a high temperature with no faster evaporation of the tungsten in the case of the vacuum lamps. The rating in an incandescent filament lamp is given with the watts and amperes specified voltage. The initial lamp light output in aluminums and approximately hours of life are also based on a lamp operated with a specified voltage. The efficiency of a filament lamp is light output with the lumens per watt of the power input to the lamp. For convenient large lamps will then vary from the 10.6 lumens per watt for 25 watts. A 120 volt lamp to the 2020 lumens per watt for a 115 or 1500 watt or 120 volt lamp. The efficiency of some of the type of lamps photographically used in the high 34 lumen per watt, they have life only of 3 to 10 hours depending on the particular lamp. The advantage of the higher efficiency of the light production offsets the disadvantage of the short life in the application. Figure shows the variation of ohms, amperes, and watts, lumens per watt, lumens of life, and with the change of voltage applied with the lamp, it may not be known as a small change of the voltage accompanied by a large change in these items, particularly in lumens and life. Figure 4 shows electrical discharge lamps, watts, ohms, amperes, lumens, percents, normal volts, percentage of life, percent of ohms, amperes, watts, lumens per watt, and luminaires from 0 to 180, from percent of normal volts to 40 to 140, and percent of life 0 to 400. Electrical discharge type of the lamps are disclosed in two major groups, namely mercury and fluorescent. The mercury lamp's general lighting of the surface consisting essentially within any air tube with a quartz with a hard glass withstand with a high temperature and resulting from the lamp that the capitals of the normal wattage of the outer tube is made of the hard and soft glass. Depending on the lamp type, the outer tube shell filled with the arc tube with changing the temperature serves to filter certain with the wavelengths of the arc of the radiation. Two main electrician massive electrode codes. Electrodes are located at the opposite end of the inner tube near the upper main, with the electrode is third and starting electrode. A series of balancing resistors connected with the lower main electrical wire. The arc tube contains a small amount of argon gas facilitated with the starting the arc before the mercury is vaporized. The voltage is applied with the electrical field with the setup between the starting of the electrode and adjacent with the main electrode. The ionizing potential causes the current to flow as the main arc strikes the heatly generated gradually vaporizes in the mercury. When the arc tube is filled with the mercury vapor, it creates a low resistant path of current flow between the main electrodes. And this takes place during the electrode, and the high resistant path automatically becomes inactive. Figure 5 shows a principal part of the mercury lamp. The nominal screw, the starting resistor, the starting electrode, upper main electrode supporting the arc tube, lower main arc tube, the support and outer tube. Light is obtained with the mercury lamps by passing electrical current through the mercury vapor. The emitted appears with the blue, green, white. In the absence of the red radiation, the lower the medium pressure of the lamps must be colored with the objects to appear with the distort the color value. Blue, green, and yellow colors are emphasized. Orange and red appear brownish and black for a reason because there are several minutes may be required to restart of the mercury lamp after the monetary power of the interruption on the incandescent lamps are often combined with filament lamps installation. The color improved with the mercury lamps are now available to various sizes ranging from 100 to 1,000 watts. The fluorescent coating is applied with the inside of the outer bulb. The coating is advised with the ultraviolet radiation cover to the air energy otherwise wasted into the light with the fill with the red portion of the spectrum. The resultant color of the light is about the same with the obtained from the use of the equal wattage of the mercury and filament lamps. The electrical has an error negative resistance characteristic, therefore current limit lighting equipment is necessary. The equipment can hold a ballast limited current with inducing of its windows, windings, and they introduce some wattage loss that has a pour factor of about 450 to 60%. Low pour factor usually corrected with a capacitor, which is built in the ballast. It uses the power factor of about 90%, and the better the ballast is designed with a specific voltage frequency lamp in which are they there to be used. Fluorescent lamps are classified with electrical discharge and consist of the tubular bulb with the electrode are sealed within such each end of the tube with a smaller amount of the mercury, small amount of the argon kryptonite gas is facilitated starting. The bulb is coated inside with the fluorescent powders and phosphorus. It operates more like a mercury lamp than the flow of the current type that becomes the mercury vapor. However, the fluorescent lamp and mercury vapor pressure can currently dissociate the density and voltage regulated with the discharge produced. Very little visible and directly does crowd as much as energy as possible into an ultraviolet radiation of one specific point. The 2537 agnostrometry in line with the phosphor receiving the radiation convert the short wave ultraviolet radiation into visible light. This shows figure 6 is a cutaway sketch showing the construction of fluorescent lamp tube filled with argon gas, mercury vapor, the mercury inside with the coated fluorescent material, and cathode coated with the active material. The efficiency of a fluorescent lamp is much greater than the incandescent lamp than the standard. The warmer the white colored low lamp efficiency ran with the 26 of the per minute, and the 4 lamp to the about 69 lumens per watt. 96 instant starlining slimline lamp continues at 74 watt. The fluorescent lamp is a fairly rapid decline in light output during any of the part of the life. During the first 100 hours, burning of the main point with 10%. However, the deterioration of remaining life of the lamp is less rapid. The depreciation of light output is due to the chiefly gradually deterioration of phosphorus powders with the blackening inside of the tube. The lamps are used for the more unstable before burning for the reason of general practice for the burning of the all electrical discharge lamps of 100 watts or before rating. The 100 hours are actually considered initial rating. The fluorescent lamp is excellent with the obtained color and light, since most of the cases of the fluorescent are used to generate the color directly. The filament light colored with the light is obtained, meaning of the absorption filters, which allow desired color to pass through. Fluorescent lights are similar to mercury lamp that is also requires auxiliary lamp equipment to limit the current. The auxiliary equipment for the preheating cathode type of the fluorescent light and consists of 1. A step transformer in line with the voltage and not high enough to start the lamp. When using the transformer to put the same container in is the choke of the coil. 2. An automatic starter. This allows the current to flow through the 2 cathodes when the line switch is closed, heating them so that they will readily exit electrons, thus starting the opening and the lamp starts. 3. Ballast and choke. This applies inductive voltage kick when the starts opens from the aiding of the starting of the lamp. It also limits the current of the correcting operating valve of the lamp. Capacities is used to raise the power of the factor of the lamp auxiliary equipment to 90% greater. Ballast design is determined with the fluorescent lamp to be used with a circuit voltage frequency. The type of fluorescent lamp circuits. The fluorescent lamp can be grouped into two main categories: preheat and instant start. The preheated group with the two distinct starts with a switch start and rapid start. Instant start group is they are also a type of the slimline and lamps designated simply in the instant start. The identifying physical feature of the two types of the instant start lamps are bases of a slimline lamps and also have a single pipe and pin base. Of the instant start lamps have a short bi-pin base. Also, these lamps require the bolts ballast to control the current supply. The description of their operation to develop them feature further. Every fluorescent lamp with negative resistive characteristics inherent with electrical discharge type of the operation. This means if once the lamp starts mercury vapor through the current passes cannot stabilize current flow. The vapor and gas alone will draw so much current operation that the lamp would be impossible. So a current limiting devices could call the ballast must be used for the circuit to be keeping the current flow with the stable and consistent with the purpose of the light direction. The ballast alone with the may suffice with a single low voltage watt lamp. In general uses, however, then other device of the capacitor must be employed with the correct relatively lower power factors. Operating with the ballast capacitor added to the lamp circuit to bring the power factor be closer to the utility unity and will ensure the economic current rates of the consumer. The figures and the option captions following the illustration describe the details with the principal categories of the types of fluorescent lamps. Figure 7 shows a simplified circuit with the preheated with the start fluorescent lamp, which the line is closed with the current passing through the ballast. Automatic starter with the cathodes at each end of the lamp. The current with the heats of the cathode causing the active material in which the coil is cooled. Cathodes have been coated with electrons electrically charged with the gas around the cathodes. The preheating current is approximately 50% higher than the operating current. The automatic starter opens the preheated circuit with the cathodes seconds, leaving the gas in the lamp only with the current path between the cathodes and the current flowing for the ballast has created the magnetic field around the coils and windings through the metal. This shows an automatic starter, two lines of capacitor going through the backs, current ballast, current capacitor in between, capacitor ballast within the line of the tube filament, automatic starter. Alright, the core. When the automatic starter opens, the magnetic field collapses, causing a high voltage surge. The voltage surge and the force of the strikes or arcs on the lamp. Figure 8 shows the circuit of the single 40-watt rapid start with the rapid start lamps that continuously heated with the cathodes, with the circuit closed with the start automatically with the aid start required with the preheated switch start lamps. The heater winding should then shown in the circuit diagram are in part of the ballast to provide with the current flow with each of the cathode at all times. The lamps is operating the current heats of the cathode, which that causes electronic emission prior to starting, just as the case of the switch starting preheated lamp. The rapid start of the ballast provides with enough of the open circuit of the voltage across the lamp to make start of the automatically almost as soon as the cathode emission begins. Rapid start lamps will be given in performance in luminaire circuit of the desired preheat. Switch start lamps with either the glow switch or the terminal switch starters. If the start of the rapid starts in the preheated with the circuit of the glow switch, the type of the recommended, but since the thermal switch is the starts, but they may be caused this earlier discolorization of the rapid short lamps. Preheated lamps are not placed in rapid start circuits and does not inadvertently. The lamps generally will not start. However, they should. Figure 8 shows Figure 8, and however they should show the lamps should the short life with the result of the insufficient preheating of the cathodes. All instant start lamps, both Slim 9 and Instant Star, have special design cathode constructions known as triple coil winding. The triple coil construction not only holds the considerable amount of the active materials firmly in position, but also permits hot spots in developing quickly. The greatly produces the amount of activating material used in the starting of the lamp. Each of the cathode coil and instant start lamp is shortened itself, and since the cathodes are not preheated. Figure 9 shows the circuit of the two slimline lamps. The instant start lamp requires no start of the preheating with the cathodes. Lamps are actually started with the brute force applying with a much higher opening circuit, and the cathodes applied with the best heat lamps. The ballast of these lamps are built with large step-ups and transformers to provide high open circuit voltage. This shows a typical fluorescent lamps Part 3. Fluorescent selection of fluorescent lamps.